Hello, my name is Bogdan and I'm a physicist. My goal is to build together with you an intuitive and easy to understand theory of nature that will explain all the observations we have made so far about the universe. Thank you for joining me on this journey. In the last episode, we discussed about the scientific method or how to build a scientific theory. And we've seen that it all starts with making some observations, then formulating a hypothesis or asking some questions about it, running some tests or experiments, and drawing some conclusion. We also mentioned that there's no correct physics theory, that all theories we know they are incorrect, but at some level they are a good approximation of the physical phenomena we observe. And yet, we ask the question, why, even if the theories are not correct, why do they still emulate nature to a good enough degree? This is a question that has puzzled scientists and philosophers for quite a while. Why would nature obey human mind, and why would nature obey mathematics? Why would we be even able to explain how nature works through logic and mathematics? Would actually nature solve equations and do all the things we do when we calculate the trajectory or we try to predict the outcome of an experiment? Mathematics was a concept invented by the human mind. It's an abstract concept, and yet it's our best tool to make predictions about nature, and our equations are best to describe the physical phenomena we observe. Therefore, there must be some link to how nature works, right? There is no reason why nature should obey our mathematical laws, our logic, or even our understanding, and yet it does. This is a very interesting question, and we will explore this in today's episode. In order to answer this question, let's take a step back and look at how the human mind works. Let's see how we internalize the experiences we have. We communicate with our environment through several different channels, which are our senses. For example, we can see things, we can smell things, we can taste flavors, we can hear sounds, we can touch things and get information about the environment. And through all these channels, we do gather information from our environment, then that then is processed by our minds, our brains, and we create or internalize, we create an internal picture of what's going on out there. One peculiar thing our mind is very good at, and this is the core way we function, is we tend to categorize and classify things, meaning when we receive information about or stimuli from the environment, we tend to pull them in boxes based on similarities. For example, if I mention a red apple, maybe in your mind the image of a round object of color red will form based on your previous memories or experience about interacting with such an object. Maybe your mind will remember the flavor the apple had when you bit into it, or the crunchy sound it made, or how smooth it felt in your hand when you touched it. And this is all based on your previous experience or memory of interacting with such an object and all its qualities you gathered about it. And all these experiences form for you an image or an object in your mind called red apple. And your mind is really good at doing two things. It can generalize or it can restrict the categories. For example, red apple is a subclass of a more general class called apples. So the more properties we mention about an object or experience, the more we restrict it. And the more we restrict it, the better we express it or we convey more information about it. On the other hand, the more generic we go, the more other objects we can include with our description. For example, a red apple is a subclass of an apple, which is a subclass of a fruit, which can be a subclass of a vegetable or a plant, which is a subclass of biological matter, which is a subclass of matter. So the more we want to include in our description with or describe more things with fewer words, the less restriction we will have to apply to that particular object or class that you define. So you see, when we are trying to describe or transmit information about an object or phenomenon, ideally we want to transmit the most accurate information we can. Meaning we want to go to the most restricted subclass about the object and describe all of its properties that we have access to. And by doing so, we are able to convey information about this particular subclass or category that we talk about, we are trying to describe. But in doing so, we encounter two problems. One, as we will see in the future episodes, is that the systems or phenomena we interact with have some limitations in how much information they can share with us. Information is not just an abstract concept. Information actually conveys into physical properties. And the more information we gather about the system, the more the system becomes unstable. Meaning that if you were to know all the information about a system or phenomenon in particular, that system would actually cease to exist. And therefore, there are some intrinsic limitation in how nature works and what it allows us to know about its creations. A second problem is when you describe in such a specific way a system or phenomenon, you restrict the classification, meaning you are just describing that particular class or object, and it's very hard to generalize without taking out some of the restrictions in order to describe bigger classes or more inclusive categories. So it's like a seesaw effect. The more specific you go, the harder it is to become a general theory that would apply to all phenomena that you can observe. And this ties very closely to how our physics theories work, and maybe to the question, why haven't we been able to build a unified theory, a theory of everything that would actually explain through one master equations everything we see in nature. Maybe there isn't anything to explain to one master equation because our minds are just structured to categorize everything, and the way that we categorize is not compatible with the way to generalize things. So an equation that would work on a very specific subclass may not be able to generalize to apply to all the classes or categories. Another very important point into answering our question about why nature obeys our thinking or our imagination, let's call it, is the fact that our minds, as I mentioned, gather information from the environment. They build mental pictures or categories based on that. But our minds are truly incapable of imagining new things or things that really don't exist. What do I mean by this? Well, when we receive information, stimuli from the environment through our senses, our minds build mental pictures of them. And they are really good, as I said, at categorizing them, at combining them, at breaking them down. But it only works with the elements it has gathered. So it could never imagine something truly outside of our experience. For example, I could put together some concepts, like I could imagine there are some banana people with cowboy hats living on a faraway planet that orbits two suns. But all I'm doing is I'm combining pre-existing concepts in my mind that are incompatible with reality, like bananas, cowboys, people, living, planets, stars, and so on. Our brains could even combine such elements in a non-conscious way or a subconscious way to create such incompatible objects with nature. For example, the color pink is a combination of blue and red that forms in our brain. It doesn't really exist outside in nature. But is this a new thing? No, because it's a color that it's made up by combining two other colors. It's similar to the banana people example. So you see, we are not truly capable of imagining anything that is outside of our perception or our interaction with nature. I do feel this is a very important point in answering the question, why does nature obey logic? And I do think that the question should be reversed. And in doing so, the answer becomes very trivial. So why does logic emulate nature so well? It's because every thought of or idea that any living being in this universe has ever had is based on an experience about nature, about the universe they live in. Logic is our way to organize and categorize these interactions we have into mental pictures about our experiences. And we can combine them in many different ways, but through trial and error, we can find the right combination that would emulate the real experience in a good enough way. So our theories in the end are a combination of mental pictures of experiments or experiences we had about nature that we combine together in a good enough way to be able to describe or classify other experiences. So you see, the shortcoming of our theories in the end is the fact that we, as I mentioned before, we will never know we are not able to know and describe any experience or object fully, knowing all its properties. Therefore, there is no theory that could predict or describe exactly how nature works. The second question about why mathematics is so good at describing nature is also simple, in my opinion. You see, mathematics, although it became abstract, it's based on logic, and it has its root on our interaction with nature. Mathematics started as a way to quantify reality, and it evolved into a more abstract element that explores all possible structures, real or unreal. But remember, even the unreal structures, similar to the banana people example, are rooted in nature. The unreal structures are just combination of real elements that are incompatible with how nature works. Thus, when mathematics is used to try to explain or predict some phenomena, the equations are molded in a way to emulate what we are trying to describe. So mathematics truly is a way to adjust our equations, our numbers, our variables to match an observation. It's not the other way around. A good analogy is that mathematics is a language. We have a vocabulary and some logic rules similar to grammar, and we can construct some very beautiful and grammatically correct sentences which actually don't convey any information. That's what happens sometimes with pure mathematics. So you can combine in very different ways and according to the rules of your grammar, the words, but not convey any information to your listener. For example, if I'm trying to transmit a message to my friend about how my weekend was, I need to choose the right words from the vocabulary and combine them in a way that makes sense using some grammar rules that we both know and accept in order to be able to convey or transmit a message to him. It's very similar with mathematics. We always mold our equations, we adjust them in order to fit exactly the experiences not exactly, but close enough the experiences we have. And we use this kind of logic or set of rules for mathematics in order to be able to transmit this message in a clear way to other people who understand mathematics, similar to other people who understand your language. I think in the end, the only remaining question, a true mystery about nature, is why nature is repetitive. Why do processes repeat and resemble so closely previous processes? Why, if I perform an experiment today and I do the same experiment tomorrow, I get very similar results? Or why, if I do it here and I do it 10 feet over to the right, again, I get the same type of results? It seems that space and time have some kind of symmetry, which we will explore in some future episodes, that makes nature interactions be consistent, be repetitive. And this is what gives our minds the possibility to predict and to build physics theories. Logic only works because nature is repetitive. Nature, although it evolves and changes, it changes in similar ways. And we don't know yet if this is true everywhere, or is it just valid in our small patch of universe where we live and at very small time scales. But this is the experience we have. Maybe logic only works locally in a very narrow patch of the universe, and maybe over time spans of millions or billions of years. But this is merely a flicker in the flame of eternity and infinity that nature is. Going one step back, I would like to remind you why I advocate for an intuitive understanding of nature. Based on our discussion today, you see that mathematics is just a language to describe what we really think happens out there. This is why it's important to build mathematics to emulate reality and not follow blindly where the equations might lead us. So even though we start with something that makes sense, sometimes we just follow the mathematics and see where it leads us and see if we find a correspondence in nature. But in my opinion, it's like you're starting a discussion and you build your sentences with words and grammar, And at some point, you stop caring about what words you use, and you just follow the grammar rules in order to have a communication, which is like you're talking while zoned out, and you usually don't transmit any information, or what you send, even though grammatically correct, it doesn't make any sense anymore. This is why it's important to mind our every word we say through logic and understanding and intuition. And this concludes our today's episode. Thank you very much for being here. I would like to know your opinion in the comment section. Do you think nature is and will stay predictable,